Hello there. So today we're gonna learn how to use Preview, and I'm on Mac OS. How did I did my B-Dyn model? So there we go. Just import the file Preview B-Dyn 2. Hope it's the good one. Perfect. So there you have the model already meshed. So geometry, you have pretty much nothing to do. You already have silicon, the cover PCU, mobile piston and base. Whenever you want to hide a component, just right click on it and you can hide it or you can unhide it, etc, etc. You can even have access to properties, and every time whenever you click on something over here in this window, the options will be shown over here. So there you go. You have the parts, faces, nodes, etc, etc. Something really cool is the curve editor. This is really useful whenever you have numbers and you want to set them exactly with a precise value, and maybe using one of the equation editor. This is really useful, for example, for density, or this is actually a constant value, but if you want to use something more like sinusoidal, it is possible. We'll come back to this later, but keep in mind that the curve editor is really useful for any type of number you want to use. So for geometry, you pretty much have nothing to do. Let's go on to material properties. For material, same thing. Whenever you want to add something, just right click on it, add material. Here you have all the options. Just click on one of them. Let's say, for example, I want to use simple isotropic elastic. Just add, and there you go. You have a new material property just created. As always, you have the options over here. I'm gonna rename it. Let's say test. Choose the color. I don't know. Let's say just something really simple. Green. Or green's already used. Red. There you go. And in this section, either you can choose the name of the part you want to add, or you can choose the domain directly from here, from the graphic user interface. And finally, you have the young modulus and the Poisson ratio. I'm just gonna use something really simple. It's just a test. So in this section, you can see there's nothing selected yet, but let's suppose I want to select one of these parts. I'm just gonna click on it and say add, and there you go. You have, it's a number because each part has got a special number. Let's suppose I want to add the piston. Just click on the piston and there you go. And you can see it has turned red, but as it's not true, I'm just gonna delete them using the minus symbol. And there you go. This is for material. When we come back to boundary condition now, you have different boundary condition. Something really weird on this version of FEBio, which is FEBio 2.5, and I don't know why, is that you don't have displacement and rotation in the same condition. I don't mysteriously it was present in the previous version, but in this one it is separated. So whenever you want to encaster, you will have to use zero displacement and then zero rotation. This is why I have base with translation and base with rotation. Same thing for silicon and piston and PCU, for example. So here you go. You can just choose one of these boundary condition. As always, let's say I want to zero displacement to impose zero displacement for zone. So I'm just going to click OK. You have to choose which of the coordinates you want to block, and let's say I want to really completely block it. Which step? Second step. I'm going to call it test BC. Okay. So it has been created, and you have, as always, the window. So either you can choose the name or you can add it. This is the tricky part because I didn't know that, but I found out really late. well, the main points that I found out. So if you want to select element by element, it's really complicated to, it's counterintuitive. So this is the only technique you have. You have to choose the component first. Let's say I want to block a part from the base. So I'm going to select the base because this tool is for selecting objects. So I've selected these objects. Then I'm going to move on to next window. So this window is producing geometries, as we already have some geometries. We're not going to use it in this tutorial. This is for modifying the geometries if we want to impose some distortions or some flexions or so on. But I'm like, we're not going to use this one as well. Turn to the next one on the right, and you have mesh. For mesh, you can choose this, and you have different tools. As it's already meshed, we're not gonna get in detail on this, but the main point is that whenever you have selected an object and you want to select element by element, you have to hit this button, select faces, and from now you can come back to the initial window and to the test boundary condition, and here you can select element by element. Let's suppose I want to block this area. I'm just gonna zoom on it. And and I can select it using the mouse and pressing shift button in the same way, and here you go, you have selected element by element, which is really counterintuitive compared to Abacus, I know, but this is how it works. As you can see, I have some more elements that I want to get rid of. You can unselect them using control and drag again, and repeat the operation, and it's perfect. Now just click on the plus button and all the numbers of the elements selected has been added to this section. If you want to remove one of them, just click and this is the thing that you mustn't do. If you want to remove only one of them, you have to use the X button. If you use the minus button, it can sometimes, I don't know why, it takes everything off. It takes everything off, so you have to be careful about this. So I'm gonna add them again and just select one of them, and there you go. This is pretty much everything. If you want to add boundary conditions, the same boundary conditions for two different parts of the model, you have to be aware that you have to separate them, because we have selected this object, and then for these elements, this boundary condition, you can't over here change object and go for a boundary condition again. It's not possible. You have to create another one, and as always, make sure you unselected everything, any elements. Go back to this. Let's select, for example, not the base, the piston, for example. So right click, I selected it. As you can see, it's squared now. Go back to mesh, element, and now you can select using shift elements easily, or unselect using control, and come back here. You can just, the elements are already selected, you can just add boundary condition, 0 displacement, 0 rotation, for example, U, B, W, and you can see the elements are all over here, already selected. This is why I told you to make really sure that all the elements from the base were unselected before moving on this different one, because whenever you add a new boundary condition, it keeps in mind the elements selected. So I'm just gonna delete them now because I'm not gonna use them. Yes, delete, and the test material, close. We need to assign this material element. I'm gonna delete. Yes, I want to delete. So this is made out of titanium. Unselect element, come back to object, titanium, and you can add them. And there you go. You have piston, cover, and the base. For the pressure now, keep in mind that for contact, it is pretty much the same method. If you want to add a new contact, right click, you can use one of the contacts available. I used only tied interface, but you can use sticky, rigid, and so on. For tied interface, you'll have master and slave to define. I'm going to call it just test again. Which step? This is really important. Normally, I don't modify anything in there because it's quite precise and accurate. Okay, come back here, and as you can see, you have a master and you have the slave. So let's suppose you want to create this contact between the piston and the silicon. You'll need to hide some elements. For example, let me hide this and the PCU. You go into this one, you select it. You want to select some special elements. Come back to this. Test for the contact for the master. I chose it as a master, but it's just an example. And just simply select elements with shift, for example. Keep pressing on shift, hitting shift, and you can choose even zones and add them. Whenever this is done, make sure that you unselect everything, hide them and unhide the piston, for example. Not the PCU, silicon, hide, and the base, hide again. Select the object. So again, we want to select the mobile piston. We want to use some special element. Select this zone. Come back again. Test. And then in the slave section, add. And this is it. There you go. Unselect everything and unhide the components. Well, this is just an example. And there you go. You have your tight surface between the piston and the silicon. Finally, the pressure or the loads more generally. So you can add, as you can see, I'm just going to come back to it. You can add boundary load or you can add a body load. For this typical case, we're not going to use body load. We're just going to use boundary load, which includes nodal force, pressure, traction, etc. If you want to use nodal force, same thing. Make sure that you select the object, come back to mesh, and selecting points, or using this small button. For the pressure, keep in mind that it's always normal to the direction. So it's always in normal direction, so it won't be kind of traction, for example. Let me explain myself. If I select a pressure for this step, load scale factor, I'm just going to keep it simple and non-linear. As I told you, you have something really cool, this tool. For my new pressure, if I want to edit it precisely, just drag this point and put it whenever you want to. Let's say, for example, 20. For the units, it is meant to be consistent, so make sure your units are consistent. So after 1 second, you will have reached 20. Depends on what you have, but let's say it's 20 megapascal. If you want, you can use it like a step or like something more linear, and you can even repeat it, and every second you would have. So it's 1 hertz frequency, and it depends on the step you selected. If you selected, for example, 4 second or 5 second for 1 hertz, you will have this load. You can use something more smooth or something more. It depends. I mean, like you have different options over here. You can extrapolate it and so on. This is why I like this tool, because it gives you a lot of options. You can even equation editor depending on the time. You can, for example, say I want to put different, for example, points. Let's say 6 point from 0 to 1 around 0. Okay, and then you can, for example, move these points this way, for example, etc. And let's say it's repeated. I don't know, just trying to do something. Let's say 7 instead. Right. So you can have something more sinusoidal, for example. Well, I should have added more points, but never mind. You got the idea. You can precisely choose for each point the place you want it to be in order to have something really cyclic. And there you go. You know pretty much everything in there. Finally, for the step you created, you can go into the properties. So you have time stepping. You can choose how many time steps you want, and the size of the step. So for this one, we will have only 1 second because you have 10 times 0.1. But let's say we want, for example, for 4 seconds, we can use 40. The solver, you have many different options over here. The analysis is really important because you can choose between static and dynamic. For the nonlinear solver, you can even choose some more options over here. I didn't change anything, but you keep in mind that they exist. And this is it. There you go. I didn't choose any constraint for the output request. Generally, it's like pressure, traction, displacement, stress, etc., etc. But you have so much more options. You can just choose between the one you want. I kept it simple. At the end, if you want to just have a quick glance to your elements of your meshes, you can use the second tool, which is the mesh inspector. So selecting objects, for example, selecting the base. Sorry, we're going to select the base, and for the base, you can have some statistics like you have some statistics over here. You can have element volume. Make sure that you don't have any negative Jacobian. So this is perfect. The type of element used, you have so many options over here, which is quite good, I gotta admit. And finally, I just want to share with you one tool which is really can be useful. It's the elasticity converter. Sometimes you need to convert, for example, Young modulus and Poisson ratios into Lamé parameters or bulk modulus shear. So this can do it for you. This is actually quite cool. And there you go. You can finally export your file and come back to the terminal, and in Windows, just simply launch and run your simulation, and you'll have everything. If you have any questions, if it wasn't clear, just don't hesitate to contact me. I'm completely available. My voice was horrible because I'm a little bit sick. I hope the sound was clear. And that's it. Thank you for watching this video.